Și acum haideți să povestim rapid cu Peter. O să fie un Skype scurt. Aveți întrebări despre conferință? Hi Peter, can you hear me?
Can you hear me?
Yes. You cannot hear me? Can you hear me? Can you hear me now? But we can hear you.
Getting better. Great. I can hear you. Did you get the presentation letter?
Yes. Yes.
Brilliant.
Can you hear me now, Peter? Okay. So if I'm putting you on the speakers, you will not be able to hear me.
Fine.
Okay, so I just put the presentation. Let me know which slide you want to go.
Yes, I'm going to follow it along on my computer.
Also, you can share your desktop if you
Oh, that's good news. Share screen. Can you see the presentation now?
No, not yet.
Sharing screen. I can see the presentation. Can you see my screen as well? Or is it just you can see my video?
No, I can just see you.
Share screen. Share screen.
Okay, now should be. Okay, yes, we can see. So I'll put you on speakers. You will not be able to hear me. Okay?
Yeah.
Okay.
Good evening, everyone. My name is Peter Lawrey, and I'm the CEO of a small company in the UK. And today I'll be talking about blockchain, in particular in Java, but some of the attempts we have made in terms of the scaling blockchain. So a bit of background about me. I've been the CEO of this company for about 5 years, got 15 people in the company, and on the right hand side you can see I've got quite a few gold badges for Stack Overflow, and in fact I have the most answers number of Java in the JVM. I also have the most answers for file I/O, concurrency and memory in any language, so I guess you know a bit of my end or interest. So as a company, what we do is we create low latency, high throughput training systems in Java for major banks. That's how we make our money, and that's how we're funded. Don't have any investors as such other than myself. And so for the purpose of this talk, we're looking at how we're transferring some of this high frequency trading expertise to the blockchain world. So We've got 2 projects now with over 1,000 stars, and we're getting in the order of 50,000 downloads a month. So we've done reasonably well in the open source space, and one of the exciting things about blockchain is that it's a way of raising capital through an open source solution. So diving into the more technical details quite quickly, so this is how the model of how our blockchain actually works. So we have our own custom platform. We're not using the existing one. We've built our own from scratch in Java, using a lot of our open source libraries as a foundation. And essentially what happens is that on the left-hand side, we have a gateway that's taking each transactions. These are being written into blocks. The important detail there is each node is creating blocks simultaneously, and it doesn't have to create them all at once, which it just simply adds to those blocks. And then it has rounds. Each round is perhaps typically 10 milliseconds, but it could be seconds if necessary. So we're expecting the round to be around 10 milliseconds, and within that 10 milliseconds, they all gossip with each other to say, where am I up to? And then based on listening to all the other gossip, each node votes on which blocks deserve to be in the next round. And then ultimately there's a vote taker that looks to see that whether you've got consensus in terms of the votes. And if you do, it can then replay those blocks. Now, one of the things I'm looking to do, so at the moment it handles simple transactions, and one of the things I'm working on at the moment is a mechanism for extending the transactions available, but doing that in Java. So you can write a couple of Java components and do a color, for example, or something pretty much already, which is distributed via the blockchain. So what is that? Well, our focus is very much on trying to make sure our core components are very tied to the capabilities of the hardware that the software is running. So we employ techniques, mechanical stability to ensure that we get the best performing out of Java on a given piece of hardware. So since we're very much focused on throughput, what sort of numbers are we looking to target to do better than? And these are, it gets in the order of 24,000 transactions per second. That's its peak. It actually is 1,007. So now comparing some very popular blockchains, at the moment Ethereum gets about 7 seconds, Bitcoin gets about 2.7. So while these are successful solutions, I think they're acutely aware of some performance scalability issues, and in particular Ethereum is actively developing a solution to improve scalability. Bitcoin, on the other hand, attempted to double the transaction rate in November last year. However, they failed. So we may find that Bitcoin isn't able to increase its transaction rate in the future. So what sort of transaction rates are we looking at? Well, for a single server, 8-core server with recent hardware, we can get bursts of well over 400 transactions per second and sustain around 52,000. So this is each of the nodes within the cluster are of about this spec. So 52,000 is pretty good, partly because that means that in a single chain we can outperform Visa. Now that in itself isn't terribly compelling. There are solutions out there that quote kind of similar numbers. Where it gets a bit interesting, I believe, is that actually if we put more hardware into each node, we can actually achieve in a single chain, we can achieve a sustained rate of about 400,000 transactions per second. And at this point, it's starting to get beyond what anyone else is claiming, and so we think we're reasonably comfortable that's a good number. Part of the reason we're comfortable with a good number is we're also looking to support multiple chains. So we're looking to use an ISO standard for regionalizing chains around the world. That scales to 4,000 chains. So 4,000 chains capable of doing 400,000 transactions a second. We're looking at about 1.6 billion transactions per second in theory. You could partition it further, but it's a bit hard to imagine what the use case would be used in more of that. So the sort of numbers that we quote is likely to be realistic for a multi-chain solution is in the order of several 100 million transactions per second aggregate. Also, it's designed such that as more nodes join the system, join the network, you would get more splitting of the subchains, which actually means that the none with the same over time. However, as you add more nodes, you get more subchains, which actually increases throughput. So one of the challenges of a lot of existing solutions is as you add more nodes, you don't get linear scalability. You, in fact, can get slower a reduction in performance because you have time to reach consensus. So what are the key operations we're focusing on? The two main ones are transfer of value. You can support any asset class, so that means we can do stable coins, virtualized coins of fiat currencies, technically we can support any digital currency, and the other key attribute is exchange of value. So we can exchange one currency for another currency. So they're the two key operations we've focused on, which is part of the reason why we can get high throughputs, is we've tried to make them super simple. We have another kind of coin which is perhaps novel, is that we have a time-locked coin that can only be used after a certain year, for example, but you could buy it now at a discount. Now, in speaking to banks, one of the things that they're looking for is, well, how do I integrate? So one of the big pain points is, how do I integrate the software and what protocol does it support? And they're fairly skeptical that the market has determined what the standard protocol will be. So we're looking to actually support fixed protocol, which is the most widely used protocol in banks, particularly for orders such as the exchange facility. One of the challenges around any kind of digital currency is the amount of volatility they experience can be pretty dramatic. If you like riding roller coasters, it can be exciting, but it's difficult to do that on a sustained basis. So one of the things we're looking to do is actually use AIs to manage the exchanges, because they're part of the system, and some measures we've put in place to help reduce volatility by back and stopping momentum from large swings in prices. So at the moment, our roadmap is to have a working prototype online. We're very close to doing that. It's available, but it has a couple of issues we're resolving. Q2, we're looking to increase the throughput to around 500,000 transactions per second for each subchain. And we're also looking for pre-ICO investment, because it's the next stage. And then finally, by the end of the year, we're looking to ICO and then be in production. So one of the things you might find two other things you might find interesting is one, we have a white paper, we have a blog which I started writing contributions as to talking about blockchain in general, but also over time our solution specifically. And we have an open source version that's available as a working prototype in Java that you can download and try and run now, which is the link at the bottom of the screen. So, does anyone have any questions?
Okay. Okay, thank you very much.